you to develop as a teacher. So before we begin, do we have any questions from anybody? Do you have any questions about anything? We all pretty cool. Okay. So last time, what do we do? What do we end up with? What do we end up on? Can anyone remember? What do we do?
We were reviewing a Zoom lesson.
Right, right. So I'm really big on giving you guys the skills about how to teach in a regular classroom. But we know that that's not what we're going to be doing in the next few weeks. We're going to be doing Zoom lessons. And so the Zoom lesson, let's just kind of review, like, what exactly do you have to do? What exactly you have to hand in? Okay. So if I look on the chart for who's going to go next week, we have Ashlyn, Kay, and Melissa. And so what you guys are going to do is you guys are going to work together. You're going to choose an activity that is hopefully quantitative. That's really, really great because you could do bar charts, simple graphs, things like that. So you're going to look for an activity that is quantitative, that uses very simple materials. Why? Because you're going to ask your audience, who is Dimitri and Katerina, to buy this stuff, to have this ready. So you can't ask them to go out and buy a lot of materials. So keep it really simple. So your team members like Ashlyn and Melissa and other folks, they're going to be working together before they even talk to Dimitri and Katerina, before they even schedule something. They're going to pick out something and they're going to do it themselves, get the materials, do it yourself to see if it works. Is your data overwhelming? Does the activity work? Not all activities do. It's a big assumption. Does it work? Can you differentiate your values? Remember Dylan's lesson? And we're saying, where he poured the material down that slide, and we're saying, well, trial 1, trial 2, and trial 3. Trial 3 was really great. It differentiated, but trial 1 and trial 2 could have differentiated a little bit more. So you want to see if there's you want to have data that is, you see a pattern, okay, an explicit pattern. And so you're getting the bugs out. You're actually maybe practicing. So Ashlyn and Melissa might have a Zoom meeting together and they're going through the experiment together and they're divvying up who does what. Okay, so they practice it. They got good data. They know who is doing what. And so they call Dimitri and Katerina and they say, hey, let's meet on, let's have a Saturday Zoom call. And so they have a Saturday Zoom call and they do the experiment. And as they're doing the experiment, they press record, the record button. All right. And so they're recording the entire lesson and it all goes well. It all goes well. But how about if it doesn't go well? So personally, I would just say, oh man, can we meet on a few hours from now? Can we meet on a Sunday and get it right? You want to get it right. That's what your team is there. That's what those audience. So when Dimitri and Katerina do their lesson and you guys are the audience, you're going to really accommodate them. You really want people to succeed. And so it might work out the first time, but it might not work out. Okay, so accommodate each other. Each team accommodates each other so that you could produce something that you're proud of. And so what you're going to do on 3/9, March 9, Ashlyn and Melissa we're all going to meet just like this at 7:30. And I'm going to give Ashlyn and Melissa privileges to be a host. And so what they'll do is as those privileges are granted, they'll be able to show their video. Okay, so we'll all watch the video and we'll take some notes because we're thinking about what kind of feedback we want to give those guys. When everything is complete, when the video is over, I'm going to ask Ashlyn and Melissa, hey, what do you like about your video? What do you like about your lesson? What would you like to do differently? And then I'm going to ask all you guys the same question. What do you like about their lesson? What would you do differently if you were doing it? And then I'm going to add my critique. And that's called their critique. And that's something that I will record, or Ashlyn will record, or Melissa will record. You just need one person to record it. And so that recording is called the critique. And that's going to be given to Ashlyn and Melissa to help them write up a formal critique individually. I haven't gone over what that critique looks like purposely because we have enough on our plate. We're trying to produce a good quality lesson. Okay. So, and at that time, like Ashlyn and on that day, Ashlyn and Melissa will send me individually a lesson plan. And you might say, why individually? We're working together. Well, I want to make sure that you know the format, that you got it down. Okay. And so I can give individual feedback to both of you. Okay. So it has to be in the format that is in my book that we went over. Okay. And that's it. Right now, Ashlyn and Melissa, they don't know about their critique. I will talk about that maybe after they make their presentation. I might do it the following week, but it's going to happen. It's going to happen very shortly around that time. Okay. That's what has to be done. Do we have any questions about that? Any questions about that? Okay, cool. Cool. We're on the same page. Now you can do the lesson with them in with PowerPoint. Okay. You could use a Zoom meeting. You could also use this thing called Nearpod, Nearpod, Nearpod. And there's actually another one that you can do that I found out. There's like three: Zoom, Nearpod, and something else. I'll probably remember it sometime. But you don't necessarily have to do using Zoom. Okay, that's your like your vehicle about how you're going to do things. But I would highly recommend a PowerPoint or something like it. All right. So today we're going to look at two lessons. We're going to finish up the lesson that we saw last week, and we're going to check it out. And we're gonna, I might stop it. We can make some comments, continue it, but it's never going to be perfect. But I think it's a strong lesson. He does some things very well. Some other things that we even talked about last week that he could do better. Okay, so let's continue with that to get a good idea about what you have to do, because you're not working in front of a blackboard, or a whiteboard. Okay, we're not ready for that, in terms of our society. Okay, so I'll share screen. And I will go to, okay. So we're going to start with this. This should be familiar. And the criticism here was like, hey, it's kind of busy. There's a lot of things going on here. Endothermic, exothermic. He has a lot of arrows. It's a little bit on the busy side. And so that was one of the criticisms. So he did the beginning of the lesson. And it feels to me right now, he's doing the vocabulary before the activity. So it seems like to me like a Flexit 2, okay, where the vocabulary comes before the activity. All right. So one of the things you should do is think about, hey, am I doing a Flexit 1, Flexit 2, or Flexit 3? Or maybe I could do like a hybrid, one vocabulary word before the activity, one vocabulary word after. Okay. Flexit 3 is the most robust because it contains a little section after you answer the aim. It's a little section that says, oh, I'm going to give you an application problem to apply it. Once again, the more we go over it, the better chances are that students will understand it and kind of like, connect it into their cognitive, into their minds. Okay. So that's kind of what we're going through. So Flexit 3 is the most robust, the strongest one, because it has that application, an additional application little segment, which could basically take up 3 minutes. Okay, so it's kind of could be a short thing. It could be a Regents question. There are some teachers who always give Regents questions, throughout their lessons. So kids are kind of prepared for the Regents exam. That's what some people do. Some people do not give Regents questions at all, and they wait until like a review time, which is about 2 weeks before the exam. Okay. Okay, let's begin. Well, let's continue.
So in green, I highlighted your vocabulary terms. feel free to take notes because we will be referring back to these words as we go on into today's lesson. So the two words we're going to talk about are endothermic and exothermic reactions. So I'm going to go one at a time, and I'm going to give you guys a chance to ask questions if need be. So to begin, endothermic reaction. Let's look at that word and break it down into its parts. Endo means inside. Thermic meaning energy, and we'll associate thermic with temperature. So if we look and break down this word endothermic, endo meaning into or inside, and thermic meaning energy or heat, temperature, we can quickly see that endothermic reactions mean that the energy is inside, or as we want to define it, endothermic reactions absorb energy from their surroundings. So they're taking in energy from the outside surroundings. Okay, typically, this is going to cause a decrease in the surrounding temperature. This is best exemplified by this image right here, endothermic. So let's look at the ice cube. Can somebody tell me where is the heat going in regards to this ice cube?
The heat's going in the ice.
Absolutely, the heat is going into the ice cube. So if the heat is going into the ice cube, what do you think is happening to the temperature of the ice outside of the ice cube? Because the heat's going in. So what's happening to the outside?
It's getting cooler.
Absolutely, excellent. I'm glad that you're making that association, because if heat is going inside and leaving the exterior, that means it must be getting colder, that surrounding. Now, in terms of chemical reactions, I want you to also associate endothermic and exothermic when you look at a chemical reaction. So every single chemical reaction has this setup. Reactants goes to the products. So in terms of endothermic reactions, we are always going to see the energy on the left side of the arrow, or the reactant side of the reaction. So every single endothermic reaction absorbs energy. Therefore, the energy is going to be on the reactant side, or the left side of the arrow. With that being said, we can start to make guesses on what exothermic reactions are. If endothermic reactions absorb energy, what do you guys think exothermic reactions do?
Release, isn't it?
Absolutely, good. They release energy. They're literally the complete opposite. So the definition is that an exothermic reaction gives off energy to their surroundings. Again, this is best exemplified by this reaction right here with combustion, or the making of fire, right? We see, where is the energy going with the flame?
Out. Away.
Yeah, it's going out. It's going away from it. Very good. So isn't this why we feel heat when you put your hand too close to a fire? It's because the heat energy is radiating out, like an endothermic reaction. But so, like I said before, with the endothermic reaction, with the formula right here, the formula for an exothermic reaction is going to be the opposite. With endothermic, it's absorbing, it's going inside, so that the heat energy is on the reactant side on the left side. If everything's the opposite with exothermic, where should heat energy be on our formula for exothermic reactions? Where is it going to be, the left or to the right side of the arrow?
The right.
Absolutely, the right side. So every single exothermic reaction is releasing energy. If it's releasing the energy, it has to be on the right side or the product side of the chemical reaction. So I told you we would go back to it. Let's use what we learned on this vocabulary slide to look back and tell me what type of reaction was depicted by the egg and the frying pan. What kind of reaction? Was it an endothermic or was it an exothermic reaction?
Endo?
Absolutely endo. Now, can you tell me why?
Because it's absorbing the energy from the heat and cooking the egg. Yeah.
Awesome job, guys. I know it's easy to mess up the two. Endo, inside, outside, left, right. But you did a phenomenal job understanding that the heat is being absorbed by the egg. And we know this. It's very easy to see because the egg cooks, which means it must have absorbed all that heat in order to cook. So this little image is actually depicting an endothermic reaction. Excellent job. Does anybody have any questions before I move on? All right, so before we start with the experiment, I just want to review hypotheses, because with every experiment in the world, you're always testing for a hypothesis. Is the hypothesis true? Is the hypothesis false? So let's just review a hypothesis. A hypothesis is an educated guess to the answer of the question. Remember when we spoke about the aim, right? The aim is, how does Alka-Seltzer affect the temperature of the water? That's our question. Now, I pose to you guys to create a hypothesis to what you believe the answer to the question is. Remember, from the scientific method, a hypothesis is always written in either an if-then statement or an affirmative statement. So what would this look like? I'm going to model and give you an example.
So what's kind of nice is that you have the aim as a banner below, and he's kind of making a distinction between the aim and a hypothesis. What's a really good way to kind of conceptualize a hypothesis is that it's just your prediction, which predictions are really good because it gets out your prior knowledge. So what I would do is I would definitely recommend having both an aim, and then you can informally get out students' predictions about what's happening. What you're actually doing is you're asking them for a hypothesis. If you want to be formal, like he is, and have students actually write out in their notebook, if this happens, I believe, I predict, then this will happen. Okay. If you want them to write it out like a hypothesis statement, that's a great idea. But when you ask for predictions, you're actually asking for a hypothesis.
Our question was, does ibuprofen affect body temperature? Some examples of a hypothesis would be, if, yeah, I highlighted the if because it starts with if you take ibuprofen, then body temperature will decrease. So this is an example of a hypothesis for the example question. If you like it better, you can also create a hypothesis that's more of like an affirmative statement, being ibuprofen lowers body temperature. So knowing what you know now, I want you guys to also keep this in mind. The molecular formula of Alka-Seltzer is this. This is the reaction that we will be doing today. All right, let's break it down. We are going to take the Alka-Seltzer tablet and put it in water. When we put it in water, there will be a chemical reaction that follows. It'll fizz, carbon dioxide, and water will be on the products of the reaction. Notice the size difference between the reactants and the products. The products are a lot smaller. I want you to keep this in your mind when I ask you to formulate your hypothesis. The energy required to break a bond is more than the energy required to make a bond. So if it takes more energy to break this tablet up in this reaction than it does to make whatever products it will. What is your hypothesis to the answer to the question? How will the Alka-Seltzer affect the temperature of the water? So to make this hypothesis, I'm looking for an if-then statement or any just affirmative statement. When I'll give you 2 to 3 minutes, and please write your hypothesis into the chat of our Zoom class. If you guys have any questions, let me know.
Okay, so this is a pretty higher order question for him to ask. He's trying to apply the vocabulary, the concepts, to a hypothesis. And so this is challenging, okay? I'm going to speed it up a little bit.
No wrong answers with a hypothesis. You're just making your educated guess to the answer to the question. So it's more or less, what do you think is going to happen when you put that Alka-Seltzer into the water? How will it affect the temperature of the water? We're not going to answer the question until we actually do the experiment. So your educated guess, there's no wrong answers. All right, so I see.
I just put, yeah.
Yeah, I got you. I'm going to wait for Giselle before we continue. All right, awesome. So you guys both made your hypothesis. Yuniette, would you mind reading?
So they made their hypotheses in the chat, okay? If you're using Nearpod, you might be able to like make that, you might be able to have students actually type into certain areas. It's a little bit more educational in that regard, but they are making their hypotheses in the chat. So he's gonna read it out.
Hypothesis for us?
Sure. So I put the water temperature will increase, getting warmer.
Excellent. So you went with the affirmative statement. The water temperature will increase. Awesome job. So, Cruz, Giselle, what was your hypothesis? Can you read it for us?
Yes, I said if you put water in Alka-Seltzer or Alka-Seltzer in water, Alka-Seltzer will observe the temperature of the water, and the temperature of the water will decrease.
Excellent, excellent, excellent job. What I really like
I'm sorry, did I say that right?
Yeah, you did. So you said that the Alka-Seltzer is going to absorb the temperature of the water, and the water is essentially going to decrease. What I love about your hypotheses, and it's not a competition, guys, but they're actually opposites. So we're going to test this via an experiment, and we're going to see whose hypothesis was correct. But you guys both did a phenomenal job identifying a hypothesis. And so now we are going to put together the procedure and actually go ahead and do this experiment. So I want you guys to give me a thumbs up or say yes if you have these materials ready. Because the materials for today will be 3 Alka-Seltzer tablets. You got it?
Yes, yes.
Awesome. A timer. Now, you could use your smartphone. I'm assuming you have a smartphone because most of the world has a smartphone by now. So yes?
Yes,
Awesome. Thermometer.
yes,
Awesome. A cup.
yes.
A measuring cup.
Yeah.
Perfect. So I'm going to turn my screen right now.
So these are the type of simple materials that you could ask your audience, your 2-member audience, to buy or to get, okay? Once again, the Alka-Seltzer is something that is, it lends itself to this type of situation. And you need to find an activity like it. That's the challenge, and that does take up some time. But look at the equipment that's being used, okay? Cup, measuring cup, thermometer, timer, and a couple of Alka-Seltzer tablets. Nice.
That you can kind of see my table without turning my computer off, hopefully. So I got the first step. Can you read the first step for this procedure, Juniette?
The first step, use measuring cup to measure out 1/4 cup of water around room temperature, 20 Celsius, and pour into your cup.
So I went ahead and filled out my 1/4 cup of water around room temperature. Guys, it doesn't have to be perfect. We're gonna try and make it around room temperature just so it matches the scale of our graph. So I'm going to take my cup, which has the thermometer in it, and I'm going to pour it in.
He's modeling the procedure. Okay. He has visuals.
Okay. Giselle, can you read the second step for us?
It says, measure the basal temperature. This will serve as your control group.
Very good. So remember, in any experiment, we need a control group and an experimental group. That is so that we can compare the data we get from both. So as you read, I'm going to now measure the basal temperature, and this will serve as our control at time 0. So the baseline temperature I'm reading right now is 28 degrees Celsius. Okay, so I am going to get my Alka-Seltzer, and can you read our third step, Junia?
Yes. Add the Alka-Seltzer.
The Alka-Seltzer. So I am not going to do this just yet because I'm actually going to record the data as you guys go. So I just wanted to model the procedure for you guys. But essentially, I'm going to drop this in with my timer ready, and I'm going to record the temperature in intervals of 1 minute, which means we already have the basal temperature. So as soon as you get that, mine was 28, you'll put it in your chart. Okay, and remember, I emailed you guys the student data collection. So as soon as you get your quarter cup of water and you measure the temperature, you will put that in number with 0 minutes. So I'll go to my group data collection right now, and I'll put that mine was 28. When you guys do it, I want you to put it on your student data collection sheet.
So this is kind of cool. It's like he's trying to present, he modeled the procedure, but now he's starting to say, well, that's how is this data going to be presented? And he has a table set up, and he has a graph set up, and he has these 4 little dots. Okay. And so let's see what he does with it. Like, how do you do graphing over Zoom? It's kind of fascinating.
After I put it in, the next time I'll measure the temperature is at 1 minute. So once it says 1 minute on your clock, you'll record the temperature. Then when it says 2 minutes, you'll record the temperature.
Okay, so here's a question for everybody. Why is he being so like step by step and like really spelling it out about what they have to do? Why? I'm like, some people might be saying, oh my God, this is like so slow. Yeah, it's not a movie, okay? It's not a film. He is doing this for a specific purpose. So why do you think he's doing that? Why is he dragging this out?
Because this is for the children initially to repeat. And children tend to forget multiple steps. Okay.
So the children that might be doing this, it might be middle school, whatever, they might never have seen this before. They're doing it for the first time. Okay. What's another reason?
He's not able to check up on what they're doing as well as when you can circulate it around a classroom. So he has to make sure that they've got it from the beginning.
Right. What else? What's another reason?
It takes time to understand like new information. They have to be able to process it. You can't just throw information all at once.
Definitely. Another reason?
I think also not to waste any time once they can just start right away and they're confident in what they need to do. Okay.
I mean, time is a big deal. He's spending a lot of time with this, but he's going to save time because if students don't know what to do, they're going to be raising their hands. He's going to be running around and explaining and re-explaining. What about the domino effect? I mentioned that a couple of times. What's the domino effect that might happen?
If you mess up at one step, all the rest of the data will be wrong.
Right. So what happens when you have bad data?
You can't draw appropriate conclusions.
Right. You can't see a pattern. And then upon analysis, you don't really know why you can't see a pattern, so you can't explain it and you can't answer the aim. Your whole lesson just went right down the drain. You have to take out your magic wand and saying, well, if the data was good, this is what you would get. And that just shows everybody that science isn't very useful. So you're wasting colossal amount of time. So you have to pick out an activity that works, but you have to model the procedure in a really careful way so that students who've never done this before can actually get useful data, reliable data, consistent data, quote, good data. Okay. So the domino effect and all your other reasons that you guys mentioned, yeah, that all comes into play. Those are all important. So let's continue.
3 minutes, you'll record the temperature. When you're done with that, let me know. Then we'll all put our data together and look for any patterns. Does anybody have any questions? All righty, so I will leave up the procedure for you guys. Make sure you have your student data collection sheet available and you're putting in those temperatures as you record. At this point, I'll give you guys 5 minutes, 5-6 minutes to do the procedure. Okay. And now it's on you. You'll see me. I'm also going to be doing it. So I'm gonna.
Okay, we're gonna speed it up through this.
Question.
We're gonna speed it up through this experiment a little bit. Okay, let's just back up a little bit. Okay.
I am going to now write our class data here on our board. So can you tell us your basal temperature when when you first got the water before putting the Alka-Seltzer in?
27.
And how about the temperature at 1 minute of Alka-Seltzer?
25.
What about 2 minutes?
At 2 minutes, 24.
What about 3 minutes?
23.
All right, Giselle, how about you? At 0 minutes, what was your basal control group temperature?
I got 30.
30. So yours was a little hotter than ours. How about at 1 minute?
I got 27.
2 minutes.
25.
3 minutes.
I also got 25.
25. All right, so Giselle, can you tell us or remind us what the aim was for today's lesson?
How does Alka-Seltzer affect the temperature of water?
Well, this was our data collection. So all three of us actually went ahead and did the experiment and recorded data. Can any one of you tell me the pattern, or if a pattern exists, tell me what it is between our data sets?
Temperature's going down. That's the pattern I see.
Temperature's going down as what?
As the minutes increase.
As the minutes increase. Giselle, do you agree, disagree?
Yeah.
Yeah, for me, it went down because it started at 30 with no time. And as the time increased, it did go down.
Okay, so it sounds like even if you look at my data, between the control group being at 28, 3 minutes after I put my Alka-Seltzers in, it actually, mine went down 5 degrees Celsius as well. It looked like Juniette's, it looked like yours went down 4 degrees Celsius, and Cruz, yours went down 5 degrees Celsius. So we must have done a pretty good job making our variables all the same, whether it be the measuring or the basal temperature, because we're all right around the same pattern of 4 to 5 degrees Celsius decrease after adding the Alka-Seltzers. Now, I want you guys to work on your graphing skills, especially because graphing will help us see this pattern more visually. So I'm going to bring up our graph, and I'm going to have my stats up. Let me just write it down real quick, and I'm going to model for you how to make this graph. So
this is kind of interesting.
8, 1, 5, 2. So I'm going to go back to my graph, and I'm just going to model, just in case you guys forgot. how to graph because I want you guys to see it visually, what's happening. So at 0 with mine, and I went ahead, and this is included in your student data collection. Of course, temperature is on the y-axis because temperatures are dependent variable. That's what we are measuring in the experiment. Time being at the x-axis, it's our independent variable because it's maintained constant. It's throughout the experiment. I went ahead and scaled it. Okay, we're going up by 1 each time. But why do you guys think I put this line here at the bottom from 0 to 20?
Because we're not looking at that. We're not.
Yeah, no, essentially you're right, because we're not looking at that. None of our data points went below 20, and I want to go up ones. So I went ahead and jumped and skipped to 0 to 20. But when you do that, remember, all graphs have to be scaled appropriately. They have to go up by the same amount each time, whether it be going up the same amount or across the same amount. We can't jump unless we put this squiggly line. So let's plot these points. For mine, at 0, it was 28. At 1, it was 25. At 2, it was 24. And at 3, it was 23. I spaced these out so it'd be better for us to see. I'm going to attempt to draw this line in for you guys to see. So I'm going to draw it. Oh. Right, so that is my graph that represents my data. With that being said, I want you guys to take your data table and now plot those points on your student data collection sheet. When you're done, I want to see them and I want to analyze what it looks like. So I'll give you 2 to 3 minutes to do so.
Okay, so let's fast forward.
In 3 Alka-Seltzers, it starts to kind of decrease in rate. The slope begins to flatten out. So I want to wrap all of this together, guys. I want to come back to our aim, and I would love for you to answer our aim in the comments of the Zoom call. I want you to take everything you've learned about endothermic versus exothermic, about what we observed in our experiment, and tell me, how does Alka-Seltzer affect the temperature of water? After you guys post the chat, I will write down our answers on our board.
Okay, so let's fast forward a little bit. They're thinking. This is important.
Exothermic.
That's what I was reading when I answered.
Yes. Hypothesis is correct. It was endothermic.
Okay, good.
All right, so we have 2 answers. Juliette says, yes, hypothesis is correct. It was endothermic. Giselle says, energy is being absorbed. So you guys are both correct in identifying that this is an endothermic reaction. So that was going to be my next question was this reaction endothermic or exothermic?
That's what I was reading when I answered.
That's okay. So that's kind of like the in-depth answer to what would be just the answer to our aim, right? How does Alka-Seltzer affect the temperature of water? So energy is definitely being absorbed. And so what happened to the temperature of the water because the energy was absorbed?
It became colder.
Absolutely, it became colder. So I'm gonna actually you said, Giselle, with what you said, and I'm going to write our answer. How does Alka-Seltzer affect the temperature of water? Alka, oh, can I type? Alka-Seltzer absorbs energy from the water, therefore decreasing the water temperature. All right, so Alka-Seltzer absorbs energy from the water, therefore decreasing the water temperature. Do you guys all agree with this?
Yes.
Awesome, awesome. So if we take a look at our hypotheses, it appears that Giselle, you said if you put the water in Alka-Seltzer, Alka-Seltzer will absorb the temperature of water and decrease. So that ended up being experimentally correct, right? Did our data support your hypothesis, Giselle?
Yeah.
It did. We saw the temperature drop off over time. Okay, so I planned a exit assessment for you guys, a closure, and it's on Kahoot. So you have a choice. Should we do the Kahoot, or would you rather just answer the questions in the chat?
We can keep answering the questions in the chat, not that we got used to it.
Yeah, I like that. Well, you know, with distance learning, there's so many different applications. There's so many different ways to do things and assess. There's some learning, academy, there's Kahoot.
Too much.
If you guys are familiar with just using the chat to answer some of these questions, that might be the best way to do it. So go ahead. There's 5 questions that are on this Kahoot. And so you can label them as 1 equals, 2 equals.
Okay.
Every single question is either going to be endothermic or exothermic, because this quiz was designed around identifying endothermic versus exothermic. So before we get started on that, I just want to make sure in summation that we understand the difference between endothermic and exothermic. So would any of you like to explain what an endothermic reaction is? Yes, Bruce?
So what I understand is that when endothermic observes the energy, the reaction of the heat is being observed from the tablet.
Yes.
So it doesn't.
The key word you said was absorb, right? The energy of endothermic is going in. That's what endo means, in. In an endothermic reaction, where would the energy labeled kilojoules be? On the left or on the right in an endothermic reaction?
At the right.
The right. So right would represent the products. The products are what's being released. Actually, in this aspect, a exothermic reaction would have the kilojoule energy be represented on the right side of the arrow. So with that being said, where would the endothermic kilojoules be?
On the left.
On the left. So now that we kind of went over everything, I want to test your knowledge. Go ahead in the chat and answer 1 equals, 2 equals, 3 equals, and the answer is being either endothermic or exothermic.
Okay, we're gonna.
I'm not going to bring the chat up. The chat is going to give me the answers I need to plan my next lesson. It's going to drive the instruction, whether or not we understand it or not. We will go over the answers, but I'm not going to project your answers. That'll be just help for me to analyze.
Let's go, guys.
Oh.
Okay, so they're answering these in chat, which is fine, except that, let's talk about the parts. So I'm going to stop sharing screen and I want to hear from you guys. So what do you think about this lesson? I guess from the modeling of the procedure, the vocabulary to the end. So there's a lot of different parts in there. So what would you guys like to, what stood out to you? We don't have to necessarily go in order, but Wasim, go ahead.
So I think the lesson was very good. Like I loved his energy, but at the beginning, like from where we started today, like I think it would have been nice if he asked the students for the etymology behind the 2 words they were doing instead of just giving it out himself. And then like instead of giving the answers to the students on the board already where they could just read off, he could have like maybe had them pop up later. I think in one case he just straight up said like, the reactants are this, the products are that. So I think if he had the students predict at that point, maybe that could have brought in their prior knowledge or something.
what I hear as you're talking is that maybe let the students speak more. Like you have teacher talk and you have student talk. And so it seems to me that, let's have the students do more talking. Although like when he spoke, he was very animated. So once again, that was really good. But I think you want to get more from students to see what's in their mind. Okay. It was nice that he did that summation, but still, I definitely appreciate what you said. Okay. More comments. What you like, what you didn't like. This is our kind of a critique. What did you like about the lesson? What would you like to do? What would you like to do differently if you were going to do it? Okay.
I liked how he did the graph and the data. Like you should ask everybody to contribute to that. What even though the graph wasn't really shown, all the students did it, and then he kind of modeled it before they did it in case they didn't know. Yeah, go ahead, Dr. D.
No, I just thought it was really cool how he put those little dots for the data points.
Yeah, that was smart. I wouldn't have thought of that.
Yeah, because you guys are saying to yourself, how do I make bar charts and graphs? To make a bar chart, you make a rectangle and you fill it in. So how about if you're going to have a bar chart with 3 columns, make 3 columns that are like different colors. And then when people give you the value, just expand the column to the exact number that you need. In his case, he made pre-made little dots and he just moved the dots where it was indicated by the data. That's how you make a graph. Okay, so Felix, go ahead.
I also agree with what Wasim said about maybe letting students talk more. Like I'm pretty sure they could have figured out those things with like the roots of the words like thermometer. I'm sure they've heard of that before, so they could relate that to thermic. So I think that could have been better. Okay,
more comments. Good. What do you like about the lesson? What would you like to do differently, Ashlyn K?
I personally really like Kahoot as an assessment. I use it all the time, but for his, I don't know if we missed part of it, but he didn't explain like where things go in chemical equations. So I'm a little bit rusty on that. And I saw on his questions that there's like a chemical formula on what to answer. So I feel like unless that was addressed in the lesson, that would make sense. But I feel like you should at least tailor your students to some knowledge to get the assessment.
Okay. Yeah, the assessment, he kind of bailed out about making it fun. So it basically just becomes like kind of a dry, unmotivating section of the activity. He could have easily done something that's a little more interesting with Kahoot. Suddenly you start to see like kilojoules. He introduces a new concept. What the hell is a kilojoule? At the very end of the activity, because it was in the summative questions. That is problematic for me. Like kids are like, what, kilojoule? What is that? So that's a concept that should have been added into the vocab. Okay, more comments, pluses and minuses.
I like how
Jonathan, go ahead.
My bad. A small thing about assessments, I do like how he at least gave a choice. At the end, he said we can do a quiz or we can do something more fun and we can try Kahoot. One thing that I was thinking about was it was only those 2 people that we were saying. I would find it interesting to see what it would be like if there was a lot more, like an entire class when he's trying to wrestle with the possibilities of problems or even no problems with an entire class. What would go on there?
Yeah, I mean, obviously, I think having an entire class would be so much better in terms of like what kind of feedback and what people are having problems with and how you're going to negotiate that. So, hopefully we will, by the time you guys do student teaching, hopefully you'll have a full class of students. Some of my folks in student teaching right now, they're in schools and they're with a whole class. So that's a good thing. Okay, more comments about what you liked. Brady?
I was going to say, this is building off what Ashlyn had. So he had chemical equations and he didn't format them correctly where you saw numbers as subscripts. He just had numbers and letters all throughout. and like it looked awful.
Yeah,
Like I'm looking at that and it's like I need to envision where everything's supposed to go. And he made a comment about how, you know, we have much smaller products than we have reactants here. And it was like one of the products was huge. And I mean, it would have been a lot easier to agree with him on that if I could see what they're normally supposed to look like.
Yeah, yeah, and how to like really simplify that equation, you know, and so I don't even know if a chemical equation is really that necessary, but I think you know he could have maybe used the words instead of the letters and numbers, and kind of focused on like acetic acid plus or whatever, sorry, Alka-Seltzer plus water yields, and then have maybe where, you know, heat. So heat
Yeah.
would be kind of like, you know, in other words, a big thing in research and science ed is always do qualitative before quantitative. Okay, understand the ideas. Once you master those, then we could put in values, because it could, the values, the numbers can kind of cloud the message, cloud the ideas of the concepts. So I agree with you. Yeah, I think that was problematic, that whole area. Do you put in an equation? Maybe you write it out. Focusing on the, you know, where is heat? Is it taken in or given off? Okay, good point. Okay, more comments?
What I noticed was when he was going over the method, he told the students that when you put the Alka-Seltzer in the water, it's gonna fizz. For me, I would let them make that observation for themselves. That's kind of ruining the surprise.
Yes, I agree. I think he has to like notch it down in terms of teacher talk. So this is all like about you guys too. How much teacher talk are you going to do? You just saw a video. I would say maybe, you know, limit, you know, cut that down 10%, 15%. Okay, ask more questions. Okay, that's one thing we're learning from this video. We're learning how important, how he's modeling the procedure really well. What else do you think we're learning? What else do you think we're learning from this video?
Well, I was kind of surprised, and I'm struggling with it a little bit, like how little you actually go over in a whole class, right? Like my recollection of school was you went through a whole bunch of content and most of it flew over your head. And in the inquiry, right? I mean, there wasn't a lot of substance. It was, so it's a long period of time for a discrete number of concepts.
Yes. You're totally on, you're totally correct. The number of concepts is really crucial. When you're doing an experiment, you're doing a lot of doing, science as a verb, and then you're also combining it with science as a noun, the concepts. And if you have too many concepts and you have procedural steps and you try to merge them, it's going to be really hard. And you know, kids don't do a lot of experimentation, so they're not used to it. Maybe when we get to the college level, we're used to like, you know, 15 concepts, and we're trying to integrate with all the data, and we're writing up a big lab report, and we're making sense of it. But young kids, you know, you're going to overload them. So my recommendation is always 1 to 3 new words. So you might say, well, then how do you get through the curriculum? Well, the curriculum is about ideas, and it also is about processes or practices or methods. It's about both of these. But when you combine them, something powerful happens if you don't overload their cognition. And that's the secret. Once you overload them, they're like, gonna be like, what? Because even in this lesson, just like he said, you have heat, and you have the surroundings, and you have we'll say the inside, the event, okay? And so things are going in, things are going out. One is called endothermic, one is called exothermic. You're already a little bit turned around, and you're trying to like, oh, and then he talked about bond breaking and bond forming on top of that. So you really have to be very careful. This is not a buffet, folks. Okay, you're not going to a restaurant and you got all that food all in front of you, and you're like eating this and eating that, and you really don't get a taste of what the dinner is about. This is a well-constructed meal. It's balanced and it tastes good if it's presented correctly and it's portioned right. That's it. Okay. And so that kind of like that's that's the mistake that teachers make when they begin teaching. They overload kids, and if they're not connected to what's going on in the learner's mind, they don't even know that they're doing anything wrong until years later, like, oh, I have to pare it back. What we're doing right now in this Hunter program, we're not going to make that mistake. We already know that when we do experiments, which is the heart and soul of science in my estimation, we have to be very careful about the new terminology, the new concepts that we introduce that are dovetailed with the methods. Okay. What else are we learning? What else are we learning? Okay, Shirley, go ahead.
I think in terms of his slide, I don't remember which one specifically, but one of them, the moment I saw it, I was like, whoa, that is too much even for me. And I've seen college lectures, right? So I think he may want to have a little bit less on his slide. I think it was the one where he had something like aim and hypothesis. I don't remember the slide number. Or
okay.
he should actually probably have slide numbers. That's one thing. Just have slide numbers, so if a student's confused, they can refer back to it. But back to my point, a little less on the slides, and I think he should show the chemical reaction with the bond stick model too, or maybe some sort of simulation to show that bonds are breaking instead of the students just taking his word for it that yes, bonds are breaking, bonds are forming, but exactly which bonds are breaking, which bonds are forming.
I think you're bringing up a really good point, like slide management. Okay, the slide management. It's like we have to think about not putting too much information on, but also using graphics. Okay, and I'm not teaching you that. I didn't teach you. We didn't have all day about like slide management, PowerPoint, and all that. But something that's coming out of this lesson is that we have to think about visualness, and limit the words on a screen. Okay. I also said, you also mentioned like simulations. I thought what we needed in this lesson was more graphics, like in and out. Like the water was the outside, the tablet is the inside. So as the water is getting colder, the heat, the energy from the water is being transferred as heat. That's what heat is. Heat is a transfer of energy. So it's being transferred from the water to the tablet. But we only can understand that if we know that the water is the outside and that the tablet is the inside. So a graphic would be great. And then what's the opposite? Exothermic. Okay. So exothermic means that it's meaningful if we know what the inside is and what the outside is. That's kind of like a key idea. So a graphic would just be really good with arrows and all that. Okay. So these are all these things that we should be incorporating into our lessons. He really did a great job on the modeling of the procedure. Okay. And people got good data. That was a successful activity. He got a pattern. He asked kids, what does this pattern mean? So that was really good. The core of his lesson, the choice of activity and the acquiring of good data from students who never did the experiment before, that's kind of like the core. If you don't have that, then you could do all these graphics and you could do this fun summative assessment and it's not going to work. Nothing's going to hold up because you don't have any good data. So his core was good, but there's other things that he could do in that lesson that you might want to take to heart. Okay. So what I'd like to do next is I want to go over you guys your questions that you did for the beginning of the chapter, beginning of the book. So what I'm going to do is it's 8:30. I'm going to put everyone into breakout groups of maybe of 2. Okay, maybe we'll just pair and share. And I want you to pick out like 3 or 4 questions that you answered in your responses, and just share it with your partner. And then when that person is done, have the other person share. And you might go back and forth, but pick out a question that was meaningful to you. And then what we're going to do is we're going to come back as a group, and I'm going to focus on maybe 3 specific questions within that set. And I just want to know what you guys are thinking and feeling. Okay. So let's go into breakout rooms for about, I would say maybe 12 to 15 minutes. So if anyone needs to take a break or, a bathroom break or whatever is good. But like pick out questions that you think are important to you in those, I don't know, maybe 30 questions that you have. So just kind of go back and forth a little bit and then we'll reconvene and we'll go over it. Okay. Okay, and I'll probably, we have an odd number, so I will put one person in a group of 3. So I'll see you back in about 15, in about 13 minutes.
Hello.
Hey, Sammy, how's it going?
It's going well. Let me make it so that you're not there alone.
Got it.
Come on. Click start. There you go.
There he is.
Hello.
There he is. How you doing?
I'm gonna pause.
Check out number 6, chapter 1. What does the shell represent in the story? How is this idea related to teaching? Okay, so you might want to look at what you said, or you might not. You might want to, you already know the answer. So what does the shell represent in the story? Let's start with that one. Okay, Melissa, go ahead.
So in the story, it was basically just representing, where they've always lived, how they've always lived in that certain environment of being within a shell. It was very comfortable and very stable. And then in terms of how it relates to teaching, and I guess tying back into the story overall, I said that I believe the shell represents comfort and stability overall, and it relates to teaching because if a teacher has a certain teaching method that they feel very comfortable with, that's worked for them in the past, they might be reluctant to open up and try new methods, even if it's obvious that the students are not meshing well with that method. They might be reluctant and scared.
Okay, good comment. Okay, let's hear from some more people. What does the shell represent to you? And how is it related to teaching? Okay, Ashlyn K, go ahead. And then Stacy.
I also said the same thing as Melissa regarding the comfort zone situation. I said in terms of relating it back to teaching, there are times and situations where people's clamshells or homes are never disrupted, so they don't know how to prepare for it. And so sometimes it takes that one groundbreaking challenge or major big idea that puts you out of your comfort zone and leads you to find another.
Okay, good. I like that. Okay, Stacy, I think you had a little check mark up there. Maybe
Yes.
Okay, go ahead.
I agree with both. I said the shell represents comfort and familiarity. This relates to teaching because teaching is something that should be evolving, and your teaching should depend on knowing your students and where they come from.
So, over the years, as you're teaching, your students are going to change. And so your ability to change with them is kind of a critical thing. It's like you don't do your own thing and let the students kind of grow and mature and change over time. You grow with them, you change with them. Felix, go ahead. You have your hand up.
I like what Stacy said, and the growing part. Like when we think of like mollusks or crabs, even though when they molt, like their shells break away, right? And you have to grow with your students, or else you just get stuck there, right? And I kind of thought of it as the shell being something hard that protects you from those changes, right? You're just stuck in there. You don't want to, evolve with the times.
Right. And, for many of you guys, you aren't teachers yet. And you're like, well, change from what? It's really like change from your past experiences, how you were taught science. And do you want to be someone different? Like, what is your identity as a teacher? Who do you want to be? What kind of teacher do you want to be? And those are kind of deep questions. But one thing I will tell you that even when you start to identify and say, hey, this is me, this is who I am, you are going to change. I think teaching is like Pablo Freire, like this kind of brilliant educational theorist. He said, teaching is political. I'm like, what are you talking about? I don't get it. Teaching is political. Well, one thing that is in the field of education is that we're always going to have, like, every few years, you're going to get mandates that you have to add this, you have to do this, new standards. And I was always like, oh man, I got to do this. It's like, but every time the change came, I actually, hesitantly addressed it. But then I kind of became a better teacher. I kind of got into a certain aspects of the new standards, and it made my teaching better. And it seems like there's a wave. Every 5 years there's a wave, and that there's some really good stuff in that wave, and there's some other stuff that's just a pain in the ass, but you can really actually change and become a good teacher. Teaching is our profession. It's changing. It's like tax. If you're an accountant, it's changing. Medicine, new technologies, it's changing. So once you find your identity, you have to have that mindset to kind of be open to new changes. We had a couple of hands. I think Melissa, or no, Katerina, did you have your hand up before?
Yeah, I was just going to share my answer, but I'm not sure if we have to move to another one.
Okay, no, go ahead. You have time.
So I wrote that the shell in the story is the set of beliefs, routines, and past experiences. All of it shapes the ways a teacher think and act, and often afraid to step out from the standard views and accustomed reality to the world of inquiry and exploration.
Nice.
Which it corresponds with what Ashley said about comfort zone.
Okay, good. Let's go check out another one. This is in chapter 2, number 2. And what was your science teacher's predominant teaching methodology when you were a learner? And so this course is really focusing on how to do experiments, inquiry, we call it. And I'm interested in, like, is this something new that that I'm presenting to you, or is it like, oh yeah, I've had years of this? What is your past experience like? Okay, we'll go to Wasim, then Katerina.
So my science teacher was, sorry, okay, I'm muted. Mostly a stay put. So basically, like yours also, like you would just, put a whole bunch of notes on the board. The students would write down the notes. And then like we'd have 1 day a week where we'd go through like pages of Regents problems. And if you were getting most of those right, then you were learning. Like I think one time the teacher even said, like, you're going to take the Regents exam and you're never going to look back at this again. So yeah.
Okay, yep. He or she is being very honest, maybe, but honest in terms of not really having a meaningful experience. If you did have a meaningful experience, you would look back on it, would shape you. Okay, Katerina, go ahead.
Pretty much my experience was quite sad because it was completely teacher-centered, and I remember teachers were using Blackboard a lot, putting the formulas and notes and equations, and we just had to memorize. So it was based on didactic materials in books rather than inquiry and hands-on activities.
Okay.
Fortunately.
Okay, Kavita, go ahead. Oh yeah, Kavita has an interesting background, which is totally cool. Go ahead.
Well, we had a lot of inquiry lesson, like, we had a lot of lab work, but also we had classroom settings where we got a lot of notes and lectures, which sometimes was quite overwhelming. Like, we'll come out and you have no idea what you really learned because there was just so much concept packed into one lesson. But the labs really helped us to understand the lectures and all the details that were in the lectures.
Yes.
So
and
it was a combination.
Right. Okay. As we know, Kavita had a British kind of upbringing in her science, which was really stressed experimental activities. It's very different. I guess I told you that a good friend of mine was from England, and I bought a book that was in that kind of like frame. It doesn't look, it's kind of like a cross between a lab manual and a textbook, American textbook. So it has all these data and these plots and these situations where you derive the concepts from the data. It's kind of cool. Very, very nice. What other backgrounds do you guys have? What about King Yu? What about your background?
I come from Hong Kong.
Okay.
And I'm not study here. I'm in high school, so yeah.
Did you have a British system when you were in Hong Kong? In terms
Yes.
of-
Yes.
Oh, okay. And was it like a lot of experiments or experimental based?
I think half, because we have experiment every week, for one section. So, is it half? I think maybe content in more portion, but we still have experiment. Yeah.
Okay. Okay. Who else? Who else wants to? How about Samuel? How about you?
And we're talking about our high school experience, correct?
Yeah. Yep. Yeah.
So I really think that my high school experience, and I'm talking about only one of my science classes, my physics teacher, I think he used an inquiry-based approach actually. And it was honestly the best class I've ever had. So I think, to me, that speaks volumes to the method. Like, I really enjoyed it and I learned lots, and it really stoked my curiosity.
Okay, that's a great, powerful testimonial, because one of my students in my student teaching, she was telling me how she became like interested in teaching, and she had this amazing chemistry teacher in high school, and it changed. It's just like everything clicked, and she loved it. She became a chem major in college. Okay, and so what Samuel is saying and what this other student is saying is that they're speaking right to you guys. They're saying, hey, we really like experiments, and we like experiments where we're not overloaded with tons and tons of concept, where we're getting some meaning out of what we're doing. We're understanding and having fun. We're like experimentalists. We're messing around in the lab, and people really like that. Okay. It's not a traditional way to approach it in the US. It's like notes on the board. You saw what I did in 1984. I don't think you really want to be in that class. Okay. If you had a choice, Samuel's class, maybe his physics teacher's class, or a board covered with notes, and we read it and we do problems, and science becomes a word problem. Okay. So we're kind of figuring out, like, what kind of teacher do we want to be, because we're going to have pressure on us. We're going to have pressure from our peers who are maybe teaching traditionally. We're going to have pressure from the freaking test, who's going to say, hey, the principal wants a high pass rate. You gotta do all these multiple choice Regents questions, and go. The content is really long. Okay. You're gonna have pressure from your experiences, all your like years and years of like subliminal and subconscious kind of influences about what kind of teacher you should be, unless you're very, very reflective and you know what kind of teacher you want to be, and you're not going to let people stand in your way. Okay. Let's look at the next question. It says, this is chapter 5, number 5, and it says, try to make a new metaphor that best describes inquiry, learning, and teaching. Start with, if learners are like, then a teacher is like. Before we answer that, what are some of the traditional metaphors that are out there that we all kind of know? What are some of the traditional non-inquiry, non-student-centered metaphors?
Students are sponges.
Okay, why is that traditional?
Because the teacher will just be, traditional in the sense like the teacher would just be at the front, like just throwing information out like it's water. And we're just like these sponges absorbing all the water that's being thrown at us and like expected to retain it without, letting too much get squeezed out or whatever.
Excellent, excellent. So what's another one? That's a good one. So, oh, he's just soaking up that like a sponge. He's learning like a sponge. You all heard that, right? What's another one?
Like students are blank slates.
Yes. So why is that a traditional metaphor?
Sorry, my button is being weird. Because people kind of just assume that students don't come with anything to the classroom. Just like, oh, what they're coming here, and I'm gonna give them the information. They're gonna learn from me.
Right, right. So other words, it's almost like it's being like learning can be transmitted from the mouth of the teacher to the brain of the student without any alteration of the signal. It can be transmitted. So sometimes it's called a transmissionist form of theory of learning. Okay, so it doesn't matter about prior knowledge. It doesn't matter if you're raised up in the Congo or you're an Eskimo. It doesn't matter, because what I say is unaffected from your prior experiences, goes right into your brain, and you should learn it. That's it. Okay, and so these metaphors of the sponge, the blank slate. Do we have any other ones that you want to? I think there's one more that's a classic.
There's molding like a ball of clay.
Yeah, right. So Brady, you're like this inert substance. I'm just going to shape you into the genius that you are today. Okay, so I'm just going to pass my knowledge right to you and then mold you. I was thinking about one more. If anyone wants to, if it comes to mind with you guys,
like empty vessels.
Yeah, like an empty bucket, right? You're like an empty bucket. I'm just going to fill the knowledge. Okay, so getting back, so these are like really old metaphors. You don't know how old these are. It's like hundreds of years old, and it's like on the tip of our tongue. I have a problem with that. I have a problem with like, why should we know that in a day and age where we're trying to make student-centered a commonality? And so we need new metaphors, and maybe 50 years from now, those new metaphors will be on the tip of everyone's tongue. Maybe that's what everyone will be thinking about when they try to come up with an image of what teaching is. So what did you guys write about a metaphor that you thought might encapsulate or represent inquiry? It doesn't have to be brilliant. It's a work in progress here. Okay, Kavita, go ahead.
I wrote, if learners are like explorers, then a teacher is like a guide.
Oh, okay. Okay. I love that idea of explorers, that's kind of cool. Okay, more people. Okay, Jonathan, go ahead.
If learners are like water, then the teacher is like a rock, and the rock guides the water, but over time the water may shape the rock.
Oh, so like a real synergy between the two. That's really nice. I like that. I haven't heard that one before. Okay, Wasim and then Felix.
So mine is like more towards basketball. Like if students are like a star scorer, then the teacher is like a point guard. Like it doesn't need the point guard to score, but like the assist can come in handy sometimes.
Oh, that's pretty cool. I really know what I should do. I really should collect all these metaphors and publish a book about like the new metaphors of inquiry. They're kind of cool. I kind of like them. Okay, Felix, go ahead. These are cool.
Mine's just a little weird, but it's like if learners are like pots filled with different seasonings and food, the teacher's like a cook that blends it together.
Oh, nice. I'm getting hungry. Okay, what else? Anyone else? Okay, oh, Caroline, go ahead.
I had a sports metaphor too, but it was slightly different. I said if students are like soccer players, then the teacher is like a coach. So at the end of the day, the teacher has to send the players out onto the field and they need to implement the knowledge that they've learned, but ultimately they also need to experiment and figure out what works and figure out who's stronger in what area. And
yeah, they're I mean, the coach can't play for them.
Right.
And there's a big line in education. Teachers can't make learners learn. Only learners can. Okay. So teachers can't make learning. Another line would be like, the responsibility of learning is to the learner. Okay, so you can't make a person learn. You could facilitate, you could encourage, you can motivate, you could scaffold, you could help organize, but they're the ones who have to really have to integrate it. That goes against the transmissionist model. The old model would be like, I can make you learn. I'm going to pour my knowledge into your mind. Okay, so I thought these were questions they weren't all, there weren't a lot of these. I thought these were really good ones, so I wanted to share with you, those. What I'd like to do now is I kind of promised everybody, what I'm going to do is I'm going to show this short, it's a TED talk about confidence. It's about, going up in front of your class and feeling that you could accomplish something. It's about when the AP or principal observes you and you want to really do well, and how can you position your body? How can you have that strong mental outlook to produce an excellent lesson? And so, as I said, a big part of good teaching is being motivated, being interested, changing your voice. But there's another way you could really kind of empower yourself. And that's through the way you handle your body. And so we're going to look at this TED talk from this Harvard researcher, and she's interesting. And it involves, it's called the power pose. And so my feeling is we should do as much as we can to help us feel confident and that we are leaders. We're also actors, and we wear all these different hats, and we're also trying to help people. We're also helping people to try find meaning in life. These are important issues. I'm also trying to be a model of good behavior. I'm wearing a lot of hats, and I'm trying to be confident through all that entire process. We're gonna check out that. So let me close. I guess I could close this. And let's check this out. Let's go to view.
So I want to start by offering you a free no-tech life hack. And all it requires of you is this, that you change your posture for 2 minutes. But before I give it away, I want to ask you to right now do a little audit of your body and what you're doing with your body. So how many of you are sort of making yourself smaller? Maybe you're hunching, crossing your legs, maybe wrapping your ankles. Sometimes we hold on to our arms like this. Sometimes we spread out. I see you. So I want you to pay attention to what you're doing right now. We're going to come back to that in a few minutes. And I'm hoping that if you sort of learn to tweak this a little bit, it could significantly change the way your life unfolds. So we're really fascinated with body language, and we're particularly interested in other people's body language. We're interested in an awkward interaction or a smile or a contemptuous glance or maybe a very awkward wink, or maybe even something like a handshake.
Here they are arriving at number 10, and look at this lucky policeman gets to shake hands with the President of the United States. Oh, here comes the Prime Minister of it. No.
So a handshake or the lack of a handshake can have us talking for weeks and weeks and weeks, even the BBC and the New York Times. So obviously, when we think about nonverbal behavior or body language, but we call it nonverbals as social scientists, it's language. So we think about communication. When we think about communication, we think about interactions. So what is your body language communicating to me? What's mine communicating to you? And there's a lot of reason to believe that this is a valid way to look at this. So social scientists have spent a lot of time looking at the effects of our body language or other people's body language on judgments. And we make sweeping judgments and inferences from body language. And those judgments can predict really meaningful life outcomes like who we hire or promote, who we ask out on a date. For example, Nalini Ambady, a researcher at Tufts University, shows that when people watch 30-second soundless clips of real physician-patient interactions, their judgments of the physician's niceness predict whether or not that physician will be sued. So it doesn't have to do so much with whether or not that physician was incompetent, but do we like that person and how they interacted? Even more dramatic, Alex Todorov at Princeton has shown us that judgments of political candidates' faces in just 1 second predict 70% of US Senate and gubernatorial race outcomes. And even, let's go digital, emoticons used well in online negotiations can lead you to claim more value from that negotiation. If you use them poorly, bad idea, right? So when we think of nonverbals, we think of how we judge others, how they judge us, and what the outcomes are. We tend to forget, though, the other audience that's influenced by our nonverbals, and that's ourselves. We are also influenced by our nonverbals, our thoughts and our feelings and our physiology. So what nonverbals am I talking about? I'm a social psychologist, I study prejudice, and I teach at a competitive business school. So it was inevitable that I would become interested in power dynamics. I became especially interested in nonverbal expressions of power and dominance. And what are nonverbal expressions of power and dominance? Well, this is what they are. So in the animal kingdom, they are about expanding. So you make yourself big, you stretch out, you take up space, you're basically opening up. It's about opening up. And this is true across the animal kingdom. It's not just limited to primates, and humans do the same thing. So they do this both when they have power sort of chronically, and also when they're feeling powerful in the moment. And this one is especially interesting because it really shows us how universal and old these expressions of power are. This expression, which is known as pride, Jessica Tracy has studied, she shows that people who are born with sight and people who are congenitally blind do this when they win at a physical competition. So when they cross the finish line and they've won, it doesn't matter if they've never seen anyone do it, they do this. So the arms up in the V, the chin is slightly lifted. What do we do when we feel powerless? We do exactly the opposite. We close up, we wrap ourselves up, we make ourselves small. We don't want to bump into the person next to us. So again, both animals and humans do the same thing. And this is what happens when you put together high and low power. So what we tend to do when it comes to power is that we complement the other's nonverbals. So if someone's being really powerful with us, we tend to make ourselves smaller. We don't mirror them, we do the opposite of them. So I'm watching this behavior in the classroom, and what do I notice? I notice that MBA students really exhibit the full range of power nonverbals. So you have people who are like caricatures and alphas, like really coming into the room. They get right into the middle of the room before class even starts, like they really want to occupy space. When they sit down, they're sort of spread out. They raise their hands like this. You have other people who are virtually collapsing when they come in. As soon as they come in, you see it. You see it on their faces and their bodies, and they sit in their chair and they make themselves tiny, and they go like this when they raise their hand. I noticed a couple of things about this. One, you're not going to be surprised. It seems to be related to gender. So women are much more likely to do this kind of thing than men. Women feel chronically less powerful than men, so this is not surprising. But the other thing I noticed is that it also seemed to be related to the extent to which the students were participating and how well they were participating. And this is really important in the MBA classroom because participation counts for half the grade. So business schools have been struggling with this gender grade gap. You get these equally qualified women and men coming in, and then you get these differences in grades, and it seems to be partly attributable to participation. So I started to wonder, okay, so you have these people coming in like this and they're participating. Is it possible that we could get people to fake it, and would it lead them to participate more? So my main collaborator, Dana Carney, who's at Berkeley, and I really wanted to know, can you fake it till you make it? Like, can you do this just for a little while and actually experience a behavioral outcome that makes you seem more powerful? So we know that our nonverbals govern how other people think and feel about us. There's a lot of evidence, but our question really was, do our nonverbals govern how we think and feel about ourselves? There's some evidence that they do. So, for example, when we smile when we feel happy, but also when we're forced to smile by holding a pen in our teeth like this, it makes us feel happy. So it goes both ways. When it comes to power, it also goes both ways. So when you feel powerful, you're more likely to do this. But it's also possible that when you pretend to be powerful, you are more likely to actually feel powerful. So the second question really was, so we know that our minds change our bodies, but is it also true that our bodies change our minds? And when I say minds, in the case of the powerful, what am I talking about? So I'm talking about thoughts and feelings and the sort of physiological things that make up our thoughts and feelings. And in my case, that's hormones. I look at hormones. So what do the minds of the powerful versus the powerless look like? So powerful people tend to be, not surprisingly, more assertive and more confident, more optimistic. They actually feel that they're going to win even at games of chance. They also tend to be able to think more abstractly. So there are a lot of differences. They take more risks. There are a lot of differences between powerful and powerless people. Physiologically, there also are differences on two key hormones, testosterone, which is the dominance hormone, and cortisol, which is the stress hormone. So what we find is that high power alpha males in primate hierarchies have high testosterone and low cortisol. And powerful and effective leaders also have high testosterone and low cortisol. So what does that mean? When you think about power, people tended to think only about testosterone because that was about dominance. But really, power is also about how you react to stress. So do you want the high power leader that's dominant, high on testosterone, but really stress reactive? Probably not, right? You want the person who's powerful and assertive and dominant, but not very stress reactive, the person who's laid back. So we know that in primate hierarchies, if an alpha needs to take over, if an individual needs to take over an alpha role sort of suddenly, within a few days, that individual's testosterone has gone up significantly and its cortisol has dropped significantly. So we have this evidence both that the body can shape the mind, at least at the facial level, and also that role changes can shape the mind. So what happens, okay, you take a role change, what happens if you do that at a really minimal level, like this tiny manipulation, this tiny intervention, for 2 minutes, you say, I want you to stand like this, and it's gonna make you feel more powerful. So this is what we did. We decided to bring people into the lab and run a little experiment. And these people adopted for 2 minutes, either high power poses or low power poses. And I'm just going to show you 5 of the poses, although they took on only 2. So here's one, a couple more. This one has been dubbed the Wonder Woman by the media. Here are a couple more. So standing, or you can be sitting. And here are the low power poses. So you're folding up, you're making yourself small. This one is very low power. When you're touching your neck, you're really kind of protecting yourself. So this is what happens. They come in, they spit into a vial. We, for 2 minutes, say, you need to do this or this. They don't look at pictures of the poses. We don't want to prime them with the concept of power. We want them to be feeling power, right? So 2 minutes, they do this. We then ask them, how powerful do you feel on a series of items? And then we give them an opportunity to gamble. And then we take another saliva sample. That's it. That's the whole experiment. So this is what we find. Risk tolerance, which is the gambling. What we find is that when you're in the high power pose condition, 86% of you will gamble. When you're in the low power pose condition, only 60%. And that's a pretty whopping significant difference. Here's what we find on testosterone. From their baseline when they come in, high power people experience about a 20% increase, and low power people experience about a 10% decrease. So again, 2 minutes and you get these changes. Here's what you get on cortisol. High power people experience about a 25% decrease, and the low power people experience about a 15% increase. So 2 minutes leads to these hormonal changes that configure your brain to basically be either assertive, confident, and comfortable, or really stress reactive, and feeling sort of shut down. And we've all had that feeling, right? So it seems that our nonverbals do govern how we think and feel about ourselves. So it's not just others, but it's also ourselves. Also, our bodies change our minds. But the next question, of course, is, can power posing for a few minutes really change your life in meaningful ways? So this is in the lab, it's this little task, it's just a couple of minutes. Where can you actually apply this, which we cared about, of course. And so we think it's really what matters, where you want to use this is evaluative situations, like social threat situations. Where are you being evaluated, either by your friends, like for teenagers at a lunchroom table? It could be, for some people, it's speaking at a school board meeting. It might be giving a pitch or giving a talk like this, or doing a job interview. We decided that the one that most people could relate to, because most people had been through, was the job interview. So we published these findings, and the media are all over it, and they say, okay, so this is what you do when you go in for the job interview, right? So we were, of course, horrified and said, oh my God, no, that's not what we meant at all, for numerous reasons. No, don't do that. Again, this is not about you talking to other people, it's you talking to yourself. What do you do before you go into a job interview? You do this, right? You're sitting down, you're looking at your iPhone or your Android, not trying to leave anyone out. You're looking at your notes, you're hunching up, making yourself small, when really what you should be doing maybe is this, like in the bathroom, right? Do that, find 2 minutes. So that's what we want to test, okay? So we bring people into a lab and they do either high or low power poses again. They go through a very stressful job interview. It's 5 minutes long. They are being recorded, they're being judged also. And the judges are trained to give no nonverbal feedback. So they look like this. Like, imagine this is the person interviewing you. So for 5 minutes, nothing. And this is worse than being heckled. People hate this. It's what Marianne LaFrance calls standing in social quicksand. So this really spikes your cortisol. So this is the job interview we put them through because we really wanted to see what happened. We then have these coders look at these tapes, 4 of them. They're blind to the hypothesis, they're blind to the conditions. They have no idea who's been posing in what pose. And they end up looking at these sets of tapes and they say, oh, we want to hire these people, all the high power posers. We don't want to hire these people. We also evaluate these people much more positively overall. But what's driving it? It's not about the content of the speech. It's about the presence that they're bringing to the speech. We also, because we rate them on all these variables related to sort of competence, like how well structured is the speech? How good is it? What are their qualifications? No effect on those things. This is what's affected. These kinds of things. People are bringing their true selves, basically. They're bringing themselves. They bring their ideas, but as themselves, like with no, residue over them. So this is what's driving the effect or mediating the effect. So when I tell people about this, that our bodies change our minds and our minds can change our behavior and our behavior can change our outcomes, they say to me, it feels fake, right? So I said, fake it till you make it. Like, it's not me. Like, I don't want to get there and then still feel like a fraud. I don't want to feel like an imposter. I don't want to get there only to feel like I'm not supposed to be here. And that really resonated with me because I want to tell you a little story about being an imposter and feeling like I'm not supposed to be here. When I was 19, I was in a really bad car accident. I was thrown out of a car, rolled several times. I was thrown from the car, and I woke up in a head injury rehab ward. And I had been withdrawn from college. And I learned that my IQ had dropped by 2 standard deviations, which was very traumatic. I knew my IQ because I had identified with being smart and I had been called gifted as a child. So I'm taken out of college. I keep trying to go back. They say, you're not going to finish college. Like, just, there are other things for you to do, but that's not going to work out for you. So I really struggled with this. And I have to say, having your identity taken from you, your core identity, and for me, it was being smart, having that taken from you, there's nothing that leaves you feeling more powerless than that. So I felt entirely powerless. I worked and worked and worked, and I got lucky and worked and got lucky and worked. Eventually, I graduated from college. It took me 4 years longer than my peers. And I convinced someone, my angel advisor, Susan Fisk, to take me on. And so I ended up at Princeton, and I was like, I am not supposed to be here. I am an imposter. And the night before my first year talk, and the first year talk at Princeton is a 20-minute talk to 20 people. That's it. I was so afraid of being found out the next day that I called her and said, I'm quitting. She was like, you are not quitting because I took a gamble on you and you're staying. You're going to stay. And this is what you're going to do. You're going to fake it. You're going to do every talk that you ever get asked to do. You're just going to do it and do it and do it, even if you're terrified and just paralyzed and having an out of body experience until you have this moment where you say, oh my gosh, I'm doing it. Like I have become this. I am actually doing this. So that's what I did. 5 years in grad school, a few years, I'm at Northwestern. I moved to Harvard. I'm at Harvard. I'm not really thinking about it anymore. But for a long time, I had been thinking, not supposed to be here, not supposed to be here. So at the end of my first year at Harvard, student who had not talked in class the entire semester, who I had said, look, you got to participate or else you're going to fail, came into my office. I really didn't know her at all. And she said, she came in totally defeated. And she said, I'm not supposed to be here. And that was the moment for me because two things happened. One was that I realized, oh my gosh, I don't feel like that anymore. I don't feel that anymore, but she does. And I get that feeling. And the second was, she is supposed to be here. Like she can fake it. She can become it. So I was like, yes, you are. You are supposed to be here. And tomorrow you're going to fake it. You're going to make yourself powerful. And, you're going to, and you're going to go into the classroom and you are going to give the best comment ever, and she gave the best comment ever. And people turned around, they were like, oh my God, I didn't even notice her sitting there, She comes back to me months later and I realized that she had not just faked it till she made it, she had actually faked it till she became it. So she had changed. And so I want to say to you, don't fake it till you make it. Fake it till you become it. It's not do it enough until you actually become it and internalize. The last thing I want to leave you with is this. Tiny tweaks can lead to big changes. So this is 2 minutes, 2 minutes, 2 minutes, 2 minutes. Before you go into the next stressful evaluative situation, for 2 minutes, try doing this in the elevator, in a bathroom stall, at your desk behind closed doors. That's what you want to do. Configure your brain to cope the best in that situation. Get your testosterone up, get your cortisol down. Don't leave that situation feeling like, oh, I didn't show them who I am. Leave that situation feeling like, oh, I really feel like I got to say who I am and show who I am. So I want to ask you first, both to try power posing, and also I want to ask you to share the science, because this is simple. I don't have ego involved in this. Give it away, share it with people, because the people who can use it the most are the ones with no resources and no technology and no status and no power. Give it to them because they can do it in private. They need their bodies, privacy, and 2 minutes, and it can significantly change the outcomes of their life. Thank you.
Good. Okay, we are back. Comments about that. Has anyone seen that before? Okay, well, we have a few people. That's cool, very cool. Okay, I normally show this because we would be meeting in room 705 at Hunter, and you'd be giving a lesson in front of your peers, and it could be pretty stressful. Okay, sometimes giving a lesson in front of your peers is much more stressful than middle school students and high school students. And so a lot of people might be thinking, I don't know if I'm cut for this. I don't really know if I have it. I don't know, they're doubting themselves. And what this video really has shown is that you can become who you want to be. You want to be this kind of a flamboyant, passionate teacher, but you have all this doubt. You could try to fake it to make it. You could try to get into that big role, open yourself up, okay, and go out there and think of those, just do those parts. And those one part, that script that I taught you, you will just follow one after the other and just put your shoulders back, put your hands out, get big, and your body will do the rest. Okay. And so that's one way to get to where you want to be. Okay. We're all gifted with different things. We all have different backgrounds, and one of them might not be a big voice, and one might not be someone who is outgoing and kind of demonstrative. But we can get there. We can change, and that's kind of like a big theme of this course, is that we could change. We don't have to be stay-at-puts. All right, we could kind of go out there and kind of be who we want to be, little by little. And she faked it until it took years, but she got there. And yeah, it might take longer for other people than for yourself, but it's not a competition. It's about you becoming who you want to be, someone who, affects young people's lives. Okay, so I'm going to kind of end there. I know that Ashlyn, Kay, and Melissa have been talking, and they have a good plan, and so I don't need to talk to them. I would like to talk to Dimitri and Katerina just to check in with you guys to see how you're doing. But next week is a big week. I'm not going to say it's just like every other week. No, it's a big week. It's like the baton is being passed. You guys are the runners. You guys are in control. You guys, for some of you, this might be the first time you're teaching. All right. And so, yes, it's video based. Yes, it isn't, in 705. We're doing the best we can with it. But the trailblazers, Ashlyn and Melissa, and then Dimitri and Katerina, especially, and maybe even little, Brady and Samuel to some extent, you guys are the trailblazers. You guys are really important people. Okay. You're kind of setting the tone and you're setting the pace. So work hard, practice, practice, practice. Key thing, key idea, and you're going to do great. All right. So I'm going to take attendance, and then you guys could log off. What I'm going to do is I'm going to send you guys another video of a lesson. I think it's an Alka-Seltzer lesson. It's done with another kind of form of that, a different experiment using Alka-Seltzer, and it's between a woman who gives this lesson to another student, and just to see what she does. If you want, it's a Zoom lesson. How does she do her graphics? And she does her graphics really nicely. She really does a nice job with the PowerPoint. So I want to give you guys another resource that you could look at before you guys present. I think the people in the middle of the pack, like Veronica and Ashlyn, and then I think, King Yu and Hugh and Stacy, you're going to be seeing a lot of lessons. So you'll be okay. You'll see a lot of good models, a lot of critique and a lot of talk. You guys at the back of the pack, you'll be safe. Okay. It's a safe position to be, except that, near the end of the semester, there's a lot of work in other classes too. Okay. So, but I'm going to give you that for some of the trailblazers. You might want to look at it. Anyone can look at it. I'll send that out after class. Okay. So expect an email from me with that attached video. It might be large, so it might be something where you have to go to like Gmail, I don't know, Google, whatever. It might not be able to be held within in the email itself, but I'm allowing everyone to access it. So hopefully you'll get it. Okay, I'll take attendance, and then have a great week. And I will, once again, I just need to talk to Dimitri and Katerina. Okay, Veronica, I got you. Take care. Stacy? Yep.
Stacy?